Hello. Today we're going to talk about describing numerical data, and you're going to be able to describe distributions. So let's go ahead and begin. First thing we want to talk about is what we refer to as cuss and BS. That's a way to help remember. And when I say cuss and BS, I don't mean the literal type of cuss and BS that you know, but they stand for very specific things. And so the first one is the C. The C stands for the center, where the peaks are or the modes in the graph, all right? And then we're going to skip the U part and we're going to talk about the S, which is the shape. Is it symmetric? Is it skewed? Is it uniform? And then the other S stands for spread. And this is where you give me the minimum and maximum values. And then the U is, are there any unusual features? Like, are there gaps? Are there possible outliers? And the BS basically is just to remind you, as we always say, to be specific. Okay? So let's just look at some examples of talking about the center. For the center, you want to say where the peaks in the graph occur. So you would say, in this case, that the majority of the center is at approximately 5, and that's when we're talking about 5 letters in a name. Okay, and it's also it's also unimodal. Okay, there's only one peak. Okay, it's a unimodal histogram, which is at about 5. Okay, a bimodal histogram has 2 peaks, 2 very distinct peaks, okay, like it does in this one, okay, and so you would tell me it is bimodal. A histogram in which all the bins are about the same height. I mean, it's not perfect, but they're all about the same height, and you can't really distinguish one over the other. Then we want to say it's roughly uniform. All right, now when you talk about the shape, you need to be able to fold along where that's a histogram, and you should be able to fold along where you kind of split it in half, and then if you fold it over in the middle so that the two sides almost match, it wouldn't be perfect, okay, but in that case, if it does, you would say that the shape is symmetric. However, because it's not exactly, we would actually always say approximately or roughly symmetric, okay? It's not perfect, but overall, the shape is approximately or roughly symmetric. Okay, so let's go to the next one. Now, the shape, okay? If it's not roughly symmetric, you can say it's skewed. And when you tell me it's skewed, you have to tell me, is it skewed to the left or the right? And it's skewed left or right. When you want to talk about skewed, it's skewed in the direction of its tail, okay? So notice the one on the left here, its tail is towards the smaller numbers, okay? And so you would say skewed to the left, okay? Or to the lower numbers, all right? And then the one here on the right, if you notice, it's skewed, the tail is towards the higher numbers. So you would say it's skewed to the right, which is to the higher numbers, okay? Now, I do want to point out from now on, this is the only situation in which you're allowed to use the word skew, okay? Because in other situations, skew will have a little bit different meaning, okay? So, and we won't be using the word skew. So when you're talking about the shape, you can say, you're allowed to say it's skewed to the left or to the right, but only in this case. Okay, and so now let's talk about spread. And what you have to tell me, what are the minimum and maximum values? And when you're comparing two distributions, like for instance in this one, you also have to indicate which one is wider or narrower, okay? Because you're trying to compare. And make sure when you're telling me minimum and maximum values, you are putting it in context, okay? Which comes now is when we talk about unusual features, okay? So this one, as you can see, it has a gap. There's a big gap, and so it has what we refer to as possible outliers. There are 3 cities in the leftmost bound, far removed from the majority of the data. It's a good idea to say possible outliers because right now we don't know. We'll learn how to test later for outliers. But at this point, all you can say is that it's a possible outlier. Now, and of course, as all along, when you're talking about the center, you're talking about the spread, you're talking about the shape or any unusual outliers, you're always talking it in terms of context. Okay. So that's where be specific is. Okay. Don't just tell me it's wider from 8 to 10 when you don't tell me what 8 to 10 represents. Okay. So let's just do some practice here. So here's one. And we always start with the center. And we can say that there is one center, right? It is, so it makes it unimodal. And we would say that the distribution of hours of sleep has a center at around 7 hours of sleep. The shape. Well, if we were to fold there, we could say the distribution is unimodal and roughly symmetric. Unimodal is basically indicating one peak. Okay, now let's talk about the spread. Remember, it's the minimum and maximum value. So the spread is from 0 to around 11 hours of sleep. Okay, now we're not comparing, so that's pretty much all you would have to do in terms of talking about the spread. So now comes, are there any unusual features? Well, we know that there is a gap between 1 and 3 hours. And so we would want to say that there's a gap from about 1 to 3 hours with, remember I said, a possible outlier at 0 hours of sleep. Okay. All right. Here's another one. So if we want to talk about the center, we would say the distribution of quiz scores is bimodal, and with a mode at around 55 and another at around 80. Okay. And then let's talk about, next thing is the shape. Now, in this case, because it's bimodal, we can say the distribution is bimodal and roughly symmetric around each mode. Okay. So now we're going to talk about the spread. All right. Now it looks like the lowest to the highest, the spread is from the mid 30s to the mid 90s, because I'm not really sure where that breakdown is. So that is about as specific I can get. Okay. And remember, I'm talking about quiz score. So I could say the quiz score spread is anywhere from the mid 30s to the mid 90s. Unusual features. We can basically say there is a gap in the lower 40s with a possible outlier at around 35. Okay. So we've talked about the center, the shape, the spread, listed any unusual features. And as always, we were being specific. Okay. So now this one, let's talk about the center. This is still unimodal with a center at around 8. And in this case, it looks like 8 shoes. I think it's 8 pairs of shoes. Okay. And now the shape, we can no longer say that it is roughly symmetric because notice it has a tail. So it's going to be skewed. And we're going to talk about it's always skewed in the direction of the tail. So notice that the tail is going to the higher number. So that means it's going to be skewed to the right. Okay. The distribution is skewed to the right, to the higher numbers. Okay. Our spread, well, we notice that we go anywhere from 0 to approximately 40. So the spread is 0 to 40. And I think this is pairs of shoes, but I'm not sure. And then unusual features. This one doesn't have any unusual features. So you don't have to say that. You can just literally skip this part. You won't really only have to mention unusual features if there actually are any unusual features. Okay, so now let's talk about when you compare. I'm going to put myself right here. So, when you're comparing the following distributions for the number of hours of sleep of males and females got one night, it is important when you are comparing that you compare the two distributions and make sure you're using comparison language, okay? While still being specific about each group. Now, caution, some of you have a tendency to want to describe each one, but you never actually compare. So comparison language has to be in there when you're talking about the two distributions, okay? And so make sure you're doing that. Okay, it's in particularly make sure you're comparing when you're talking about the center and the spread. So let's look at this one and let's talk about the center. Okay. And if you notice, they both have their center, it's unimodal, and the center is about at the same place, which is about 7 hours. So you would say that the center is about the same for both the males and the female distributions at around 7 hours of sleep. Okay. Now we always hold off talking about unusual till the end. So the next thing we're going to do is we're going to talk about the shape. Well, the male shape we can say is roughly symmetrical, and the shape of the male distribution is roughly shaped. And we could say, well, the shape of the female distribution is skewed to the left. Notice it has a little tail. But you can also look at it and say, and this is possible, that you could say it would be acceptable to say that the female distribution is roughly symmetrical outside from the two outliers, which is basically in the lower numbers. So if you had taken that out, it would be roughly symmetrical. And that would be acceptable as long as you pointed out that taking out the two outliers. Okay? Notice that I'm talking about both. And notice I'm comparing both as well. I'm using comparative language. Okay? So now let's talk about the spread. Okay? So you're going to be specific, and you're also going to talk in comparison language. Is one wider? Is one narrower? And such. So we would say the spread for the females, which is from 0 to 10, is slightly wider than the spread for the males, which is from 3 to 11. And we could also say that the overall male distribution is slightly shifted to the higher numbers. Okay, this is where you're making comparison. Now, are there any unusual features? Well, the males don't have any unusual features, and you can pretty much say that. You don't have to talk about the male distribution. You just have to talk about the female distribution, and you can say the female distribution has two possible outliers below 2. The male distribution doesn't have any unusual features, okay? Once again, you don't have to, if it doesn't have any, you don't have to mention, but you do have to talk about the fact that the females have a possible outliers. And remember, you say possible, okay? Because we don't know. So now I'd like you to describe this graph. Sorry, let me move so you can see what it is, and I'll give you a chance. And if you notice in this one, it says, which college or school do you think you are most likely to seek a major? Okay. And notice that health medicine or medicine is the highest major mostly sought, okay, based on this. So let's look at this. What about this graph? Well, looking at this graph, what do you notice? It's still health or medicine is the major most likely to be sought in college or school. So, how is this different than the other graphs we saw? Well, this is because, and why it didn't change when we moved it around, this is because you never cuss or and BS for categorical data. It makes no sense, right? Because it doesn't matter what order the graphs are in or the categories are in, it's the information isn't going to change, okay? And so you're only going to, with numerical variables, you cannot just move the categories around, which is why it's useful to talk about the center, the shape, and the spread. Okay? So that is all for today, and I hope that you have a great day. See you next time.